So let us now migrate to the complex circuits, which involve the Kirchhoff's first law and the Kirchhoff's second law. So let me look at this question. Example 4. Calculate the current I1, I2, and I3 in the circuit below. Look at the circuits. If this point is so, and here having resistor, at this point, two resistors are parallel with each other. Yes. So this is what? Resistor. This. Yes. So let me call this place. We have 20-volt battery. The resistor here, let's call it what? 3 ohms. The resistor we have call it 7 ohms. Three ohms. Okay. Let me say this place is 4 ohms. And this place, let me call it 6 watts. 6 ohms. And this is a what? A junction. This is also what? A junction in the circuit. You are now asked to find the current I1, I2, I3. And here is that this is direction of the current. This is current I what? I1. And here we have current what? I2. So this place is current what? I3. Look at this kind of what? Of question. We are asked to find the current I1, I2, I3. If you look at the first 3 questions that we solve, we are looking for just one current. Here, we have how many currents now? 3. So, before we can know the value of these 3 currents, we apply the Kirchhoff's first law and the Kirchhoff's second law. So, let's go. Solution. The first thing that we do for this kind of question, apply the Kirchhoff first law. The first law states that first law states what using Kirchhoff current law, we state that what sum of the current entering a what a junction is equal to the sum of the current leaving the what the junction. So this is a junction here. Note. So this current I1 is going to the junction. Current I2 and I3, they are leaving the what? The junction. Have you now? So from the expression, you can have what I1 is equal to the what I2 minus what I3. Sorry, I1 equal to what I2 plus what I3. This is the what Kirchhoff's what first law. We call it what equation what equation 1. The next thing that we do you know it? Kirchhoff's second law. We can now say what using Kirchhoff voltage law. The Kirchhoff voltage law say that what the algebraic sum of EMF in a loop is equal to the algebraic sum of potential difference. Sorry, the algebraic sum of what? Of EMF in a closed loop is equal to the 0, or the sum of EMF of the battery is equal to the what? To potential difference drop into the what? Circuit. So using Kirchhoff's what? Second what? Law, KVL. The law says that is what? Sum of EMF minus sum of PD equal to 0. So by applying the what? The Kirchhoff's second what? Law, we must know the polarity of resistor, the charge on resistor, and the charge on cell. This is the positive, this is negative. Here is also positive current flowing like this, negative. So current flowing down like this, what do we have here? Positive. Here we have negative. I've explained how to get this to know. Current is coming down like this. Here we have positive. Here we also have negative. Abi? And this same current get to this side is come like this. The same current going like this, like this. Abi now, and this direction it will go back. The first thing we now need now is what? We need to locate the loop. So if the loop here is this is the action of the loop, we have loop what? Loop 1. And I also take direction of loop what? Of loop 2, like this. Let me leave loop 2 first. So what is loop 1? The loop 1 is started from this cell, going to the what? Resistor here. The resistor here, let me call it what? R1. This resistor here of this one is R what? R2. Resistor for this one we call it what? R3. Abi? And we all know that is what? Each resistor will also have its own what? Potential difference. Abi? Potential difference for this R3 is V3. Potential difference for this R1 is V3, V1. Abi? Potential difference for R2 is what? Is V2. Abi? Please note that. Potential difference for this battery, we call it what? V battery. Abi? Good. Yeah, let's start from our first loop. What is the loop? One say, yeah, the loop one is telling us that what? It started from here like this, Abi. So if the loop is moving like this now, from the Kirchhoff's law, we have potential difference for the what? For the battery. Then for this one, loop is moving like this, all this direction. What happened to the voltage? It will be drop minus V1. Why do we have minus V1? The current flowing like this, and a loop and current, when they face the same direction in the resistor, what happened? The voltage will drop, which is negative. So after this, you know what? We are going like this, come to this side, this direction of the loop. Then after this R1, we are coming to what? R3. Neglect what? This side, because this is our loop. So what is R3 now? Voltage of R3. So it's coming like this, it's also drop. That will be what? Minus V what? V3. Everything equal to what? Do you have anything again? No. Equal to 0. So this VB minus this one will be what? Current of what? Of V1, I1, and a resistance of R1. This one. Resistance is what? R1 out of current, I1. Minus voltage as its own what? Current. What is own current? I3. What is own resistor? R3 equal to 0. From this circuit, we are given the word voltage of what? Of the battery, which is 20. Right? Put it here. We have 20 out of the current. It is unknown. Resistance R1 is 3 minus 3 R1. Sorry, minus 3 what? I what? I1. Then here too we have what? What is R3? 4. Can I say what? Minus 4 I what? I3 equal to 0. Good. So what can we do here now? We can make this formula, rearrange it in this form. You can have what? 20 equal, take this to this side. We have 3I1 plus 4I3. Abi? But please, this I3, I want to eliminate it. This R3, I want to what? Eliminate it to be in form of what? I1 and I2. For doing that, I can say from equation what? 1. What do we have? I1 equal to what? I2 plus I3. Abi? Let me make what? I3 the subject of the what? Of the formula. I'm going to have what? I3 equal to the what? I1 minus I2. From this, I get this. Let me substitute for what? I3 here. By substituting for I3, I'm going to have what? 20 equal to the what? 3I1 plus 4. What is I3 here? It's I1 minus I2. Good. You will now have what? 20 3I1, 4 times I1 plus 4I1 minus 4I2. Minus 4 what? I what? I2. Good. By adding this together, I'm going to have what? 24 plus 3 to give us 7 will be equal to the what? 7I what? I1 minus 4I what? I2. Yes, good. I can call this what? Equation 2. So let us look of what? We are done with this first loop. So let's take the loop for the second close here. So this will be the what? Loop what? Loop 2. Loop 2, the second loop. So this second loop comprises of what? R3 and R2 alone. The first loop, R1 and R3 and a VB source. So by taking the loop for the second loop, let's say what? From loop what? Loop 2. Maybe second what? Second loop. This one we get here, I forgot to put it there, to put it here. This one is from what? Loop 1. This is loop 1. So from loop 2, let me start my reading from R2. When the current is flowing from positive to the negative like this, and the current and the loop, they face the same what? Direction. You know that is what? The voltage will drop. Current and loop the same direction, so you will now what? Minus V what? V2 minus what? V2 voltage drop. So voltage drop we have minus like this, and the next one is, you know, is moving like this. This is the loop direction. After this, you go to the what? R3. So when the loop is moving from negative to positive here, and the current coming down like this. So when the loop travel in opposite direction with current, check the case I gave you from the beginning. It will give you what? Positive. So it will be what? V what? V3, V3 is will be rise plus V3 equal to the what? 0. This is the V2. Loop and current, the same direction. Voltage drop. Loop is going like this. Current is coming down. Loop is going up. Loop and current in different direction. It will be what? The voltage will be rise. Now I'm having plus here. So change it to the IV. We have R1, sorry, R2 plus R3 equal to 0. What is R2? R2 is what? 6 ohms. R3 is 4 ohms. Substitute for R2 here. We have 6 the current of I2 is R2. Current of what? I3 is also what? I3. Yes. Current of I3 is also what? I3. So I'm going to have what? 6I2, then plus R3 is what? 4 what? I3 equal to 0. But don't forget here, what is my I3 here? Is this. Substitute for I3 here, you have 6 I2 plus 4. What is I3? Eh, I1 minus I what? I2 equal to 0. 6 I what? I2 plus 4 I1 minus 4 I2 equal to 0. If you add it together, this minus this, we have 2 I what? I2 plus 4 I what? I1 equal to 0. From this expression, we can divide both sides by what? You have 2 here, 2 here. So 2 here 1, 2 here what? 2. You can have what? I2 should be equal to the what? Plus 2 I1 equal to 0. So from this expression, we can say what? I2 is equal to what? Minus 2 I1. Call it what? Equation 3. Yes? So you can, if I2 go to the what? Minus 2 I1 is this. Let me substitute for what? I2 in the equation what? In this equation. Yeah, let us do that now. Substitute substituting for what? For I2 in equation 2. Equation what? 2. So we now have what? 20 equal to the 7I minus, what is I2? The I2 here is what? Minus 2I minus 2I1. We now have 20 should be what? 7I1 minus 2 times 8. Math times minus 8I1. By adding it together, it gives us what? 15. 20, if you have 20, sorry, 15 I what? I1. So therefore, the I1 equal to the 20 over what? Over 15. Please, let me put the calculator. 1.33 ampere. So therefore, the I1 is 1.33 ampere. So if I1 is 1.33 ampere, let's substitute for I2 here. Substitute for I1 in I2 equal to the minus 2 I1. So therefore, what will be the I2 now? Is minus 2 minus what? 2 I what? I1. What is I1? I1 is what? 1.33 this. It will give us what? Minus 2, 2.67 minus 2.67 ampere. Okay, so the I2 here is what? Minus 2.67 ampere. It is possible to get negative answer in Kirchhoff. But here, for this kind of what of circuits, and with this kind of what of loop arrangement, it can never possible for this kind of circuits to get negative current. So there is a mistake here. Let's check back. Using Kirchhoff voltage law, we apply this, Abi, minus yes, equation 1. From equation 2, we take the loop of V2. V2 is the voltage drop minus V3 voltage rise plus equal to 0. Yes, this is the mistake here. The minus we have in V2, I'm supposed to insert it here. Can you see the mistake now? The minus here, I'm supposed to put it here. So here now, I'm supposed to have what? Minus 6 minus what? 6i what? I2. Good. Please let me change it here now. So this will become what? Minus 6i what? I2. The minus here, I will meet it before. Put it back. We have minus 6i2. Okay. Minus 4 plus minus 6 to give us what? Minus 10i2. We have minus 10 what? I what? I2. So here we have what? 2. Okay. And I say what? This is 4i, 10i2. 2 here, 2. 2 here what? 2 in 4, 2. 2 in 10. It remains what? 5. Good. So I2 here will be what? 5. I2. Where the what? Minus 2i what? I1. So instead of calling this one what? Equation what? 3. You can now say what? I2 will be equal to the what? Minus 2 over 5. Yes, sorry, it's a mistake here. Okay, this minus there again. Can you imagine? The minus cancel what? Minus a. So now what? I2 will be what? It will be 2 over 5. I what? I1. So you now call this one what? Equation what? Equation 3. Yes. So can I say what? Substitute I2 in equation what? 3. In equation 2. Substitute for I2 in equation 2. This is equation 2. So what is my I2 now? Please, permit me to rub this side. Okay. We have what? 20 volts. No, this I2. 4I2 here. 4I2. What is I2 here? I2 is what? 2 over 5. 2 over 5. I what? I1. By putting what? I2 to this side. So 27 I1. Oh, 4 times this, we have what? Minus 8 over 5. I what? I1. So find the LCM here. 5 times 7. 5 times 7, we have 35 I1. Good. Minus 8 over what? Over 5. I what? I1. So cross multiply. 20 times 5. We have 20 multiplied by 5. We have 8. 35 minus what? Minus 8. We have 27. We have 27 what? I1. Good. Here we have 100. 100 by what? 27 I what? 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 100. 100 by what? I1. So divide both by what? By 27. We have I1 equal to the what? 100 over what? 2, 7, which is 3 point what? 7 ampere. So the I1 is what? We now have I1 should be equal to what? 3.7 ampere. So if I1 is 3.7 ampere, substitute for what? I1 in equation 2. Sub for I1 in equation what? 3. What is equation 3? I2 equal what? 2 over 5 I1. We now have 2 over 5. What is I1? Is 3.7 ampere. 3 times this. 3 times 2. 2 times 3.7 divided by 3. Huh? Sorry. Oh God, what happened to me this evening? Divided by 5? Yeah. Huh? 1.48 ampere by approximately I2 will be what? 1.5 ampere. So, we are back to the equation 1. So that is what? I2 plus I3 equal to the what? I1. So, from this is I1, this is I2. Have you now? Yes, from this expression, substitute for I3 from I what? I3 equal to what? I1 minus I2. What is I1? 3.7 ampere. What is I2? 1.5 ampere. That will be what? 2.2. Therefore, the R3 will be 2.2 ampere. So if we add I3 and I2 together to give you what? I1. So that is all about what? The question. So I will give you one more question on this. Look at the example 4 that we solved that time. It's comprised of what? One cell, 2 resistors, or 3 resistors. But look at this one. It's comprised of how many watts? It's comprised of how many cells? 3 cells, 2 cells, and what? 3 resistors. We have to find the current. Not single current. Current 1, 2, and 3. Let us look at our direction of the current. This is 10 volts, this is 30 volts. Which one is more? Bigger, it's 30. So the direction of our current in the circle started from there to come like this. This will be the current what? I1. Getting to this side, this current I1 splits into 2 like this. You can call this place what? I2. Abi? You can call this place what? I what? I3. So the current is continuing to flow like what? Like this. Like this. So like this. So these two will join together here and move again like this. So that's how the what? Direction of the current flow in the circuit. So the next thing that we need now is what? You cannot say from solution. Solution, good. You can say from Kirchhoff's what? From Kirchhoff current law. Some of the current going to the what? To the junction. Because some of the current leaving the junction, which is what? I what? I1 equal to what? I2 plus I what? I3. The current in the what? In the junction. So we can call it equation what? Equation 1. The next thing we can also say what? From equation 2, from Kirchhoff voltage law, the sum of the what? Of EMF in a loop is equal to the what? 0. You can now say what? Kirchhoff's law for loop what? 1. Take the direction of the loop in this form. This is the direction of the loop. Let me call it what? Loop 1. By taking the direction of the loop in this form, the next thing we need to do is what? Let me check the polarity of resistor. So this place will be positive, negative, as usual. Positive, negative. You know, we use direct of current to determine that. Negative, positive. This is positive, negative. Excuse me. So from there, we have at this now. Yeah, let us look at what the voltage there. By doing that, we are going to have what? Take my loop from here. Don't forget, call this place what? Battery. Let me call this one what? V battery 1. Let me call it what? V1. Voltage of battery 1. This resistor, call it what? R1. This resistor, let me call it what? R2. This resistor, let me call it what? R3. The voltage for this resistor here is V1. Voltage for this resistor here, call it what? V2. For this resistor here, call it what? V3. Abi? Voltage for this 10 volts, call it voltage V2. Abi now? Yes. By using the words, the Kirchhoff's voltage rule, we are taking our loop from this. When the loop moves toward the positive terminal of the battery, the voltage what? Rise. So here we have what? Plus V, voltage 1, get to this side, V1. So when the loop is going like this, with current, it's going to be what? Drop minus V1 of loop is drop. Getting to this side here, the loop is coming like this. It will also what? Drop for the what? R2. We have what? Minus V what? V2. Everything equal to what? 0. V1, V1 and V2 equal to 0 for loop 1. So from this expression, this V1 is 30. We now have what? 30 equal to what? What is V1? It's 30 minus what? V1 will be what? I1, R1. You know the V1 contains I1 and R1 from Ohm's law. Minus V2 will be I2, R2 equal to what? 0. What is I2? We have 30 here, Abi. We have substitute for what? For R2. You have 30 minus 2I1 minus what is I2? 5. 5 I what? I2 equal to what? 0. Abi now? By rearranging it, we have 30 should be equal to what? 2I1 minus or plus 5I what? 2. Everything equal to 30. You can call this what? Equation what? Equation 1. Sorry, we have equation 1 here. Call it what? Equation 2. We use loop 1 to get equation 2. The next thing is what? You can say for loop 2. Where is loop 2? This is loop 2. So I can take my what? My loop like this. This loop come from this side. Good. Loop move toward the what? The positive terminal of the battery. The voltage will what? Will rise. Abi? So when the voltage rise, the VB, we have VB2 like this. Then go to what? This one. This is plus. Going like this, voltage will what? Will drop for V what? You know, minus V3. V what? V3. Then getting to this side, it's going up. The loop going up like this. When loop and the current are opposed each other, the voltage will what? Will rise. We have what? Plus V what? V2 equal to 0. Why is it that what? This one is minus. The loop moving like this towards negative for resistors. I've explained that in my beginning of the Kirchhoff voltage law. Go and watch it, please. So, and when the loop is moving up like this, minus plus, so the voltage will what? Will rise. So equal to the what? 0. What is B2? Battery is 10. What is what? V3. The V3 has its own current and I. We call it what? I3 R3 plus I2 R2 equal to 0. Good. What is current I3? We don't know. 10 minus what is R3? 3 ohms. 3 ohms current I what? 3 plus R2 is 5 ohms. I what? I2 equals 0. Collect the like times. I what? 10 equal to 3 I3 minus 5 I what? I2. Yes, at this junction, I want to eliminate this I3 and insert what? I what? I1 and I2. So I cannot say from Kirchhoff first law, from equation what? From equation 1, so you can have I3 should be equal to what? I1 minus I2, the current I2. So let's substitute for I3 here. We have 10 equal to the what? 3 into what? I1 minus I2 into what? 5. What is I2? Yes, I what? I2. So the 10 equal to what? 3I1 minus 3I2 minus 5I what? I2. Add it together. What are we going to what? To add to. Oh yeah, add this thing together. We have 10 equal to what? 3 minus, we have 3I1. Add this together. Minus 8I what? I2. I mean now, am I on the way? Yes. So this is the equation what? 3. Abi? Yes. Let us apply substitution method. Excuse me. Or I should apply elimination method. Which one can we use? Can I use substitution or elimination? Let us use substitution. From this equation now, let's make I1 solid of the formula. From this expression, we are going to have what? 3I equal to the what? 10 plus 8I2. Divide both sides by 3. The I1 will give us what? 10 plus 8I2 over what? Over 3. This is what? I1. We call it equation 4. We can now say what? Substitute for I1 in equation 2. So we have what? For I1 in equation 2, by doing that, we are going to have what? This is equation 2. 30 minus is 20, is equal to 2I1. What is I1? Is this 10 plus 8I2, everything over what? 3 plus 5I2. So if we have it in this form, we have 30, 2 times 10. It will give us 20. Yes, 2 times 10, we have what? 20. 2 times 8, we have 16I2. Everything over what? Over 3 plus 5I what? I2. Let's multiply everything by what? By 3. Take a calculator for me, please. Everything by 3. 3 times 3 here, we have 90. Will be equal to 20 plus 16I2. 3 times 5 plus 15I what? I2. Abi? Collect the letters. We have 90 minus 20 will be equal 60 plus 15 is 31 I2. Here we have what? 70 equal to what? 3 S. Okay, see mistake here again. 31 I2. We have 30 what? 31 I what? I2. So divide both sides by 31. So the I2 equal to 70 over what? 31 to give us what? 2.26 ampere. By approximately, we have 2.3 ampere for what? For I2. So we can now agree that what? Let us substitute for I2 in equation 4. Substitute for I2 in equation what? 4. What is equation 4? We have I1 should be equal to the what? 10 plus 8I2. What is I2? Now, is 2.3 ampere. Everything over what? 3. This. So we now have what? I equal to the what? 10. 8 times 2.3. 8 times 2.3, it will give us Huh? Hmm? Plus 18.4. 18 plus 4 plus 10. H. There's a mistake here. I omit I2 here. I know? Yes, I'm right. Okay. A plus this, we have 28.4 over what? Over 10. Huh? Is we answer will be 3. Don't mind me, no. We have 3 here. Why should I get 10? Thank you. I1, yeah. 9 points. So the final answer for R was 9.5 ampere. If I2 is what 2.3 ampere, I1 is 9.5. What will be the I3? Let's say what? From equation what? Equation 1. What equation say what? I1 is equal to the what? I2 plus I3. Yeah. What is I1? I1 is 9.5. What is I2? I2 is 2.3. What is I3? I3 is unknown. So the I3, it will be 9.5 minus 2.3 ampere. Subtract it, it will give us what? Huh? Huh? I3 will be 7.2 ampere. Oh, therefore, the current I1 is 9.5. Then current I2 is what? 2.3. And current I3 is 7.2 ampere. Good.